Good afternoon, everyone. Welcome to the Hydrogen and Advanced Fuels Theme Group webinar. This is an inaugural webinar. As you're joining, can you please switch off your microphones and switch off your cameras unless you're one of the presenters, and please feel free to eat your lunch as long as we can't see it on the camera. That would be great. We'll start off in a couple of seconds and we'll give an overview of the webinar series and of SPEERI, the Scottish Partnership in Energy and Engineering Research and Innovation. People are just entering just now. We're also recording the webinar series. You will receive all the presentations and you will receive a link to the recording. So you can come back to us at any time for any follow-up. Just going to, oh, that's not going. I'm just going to, trying to go down to the next page. Oh, that's working. Is that working for everyone?
Yep.
So the Scottish Partnership in Energy and Engineering Research and Innovation is a grouping of two research partnerships. We've come together under one banner. The Energy Research Partnership and the Engineering Research Partnership have already been working together historically, but now we're formally under one grouping. And the reason we've come together is a strategic integration of both the partnerships to better align and for cross collaborations between energy and engineering and to strengthen those. The partnership is comprised of 14 Scottish universities, and they're all on your screen just now. And this partnership has 10 themes. So we have 6 under energy, and this has been reduced from around 13, 14 we've had in the past. And engineering has 5 themes, of one of which is energy in the old makeup of a Scottish Research Partnership in Engineering. So all in all, we have 10 research themes, which are as much as possible cross-thematic within those headings, and we have theme champions to support collaboration across the 14 universities under each of those themes. The ones for energy, under all of those listed, the Hydrogen and Advanced Fuels is the webinar series that we are taking forward at the moment, and we hope that there'll be webinar series for some of the other ones of these themes in the future. So I'm just going to pass over to our SPEERI Hydrogen and Advanced Fuels Theme Group champion, Prof. Manjud Hussain from Robert Gordon University. We'll just briefly introduce himself and what the theme covers.
Hello, good afternoon. My name is Mamdud Hussain. I'm from Robert Gordon University. This hydrogen and advanced fuel academic group has got 14 member universities. Our main aim is to create collaborative research and providing support to SMEs or even bigger industry to make hydrogen happen. So we want to take our research from lab into real world. And to do that, we have expertise in 14 universities across all the what is needed to make hydrogen happen. So we have capacity for production, we have capacity for storage, distribution, system integration, then transport, heat and power, and of course, processing and end product. So if you want to collaborate, research with us, we can I mean, you initially contact with the SPEERI team, and looking at expertise, which is distributed among 14 universities, we can then direct you to a particular university. Our job is to, as I said, to support innovation and also create collaboration. In terms of my research at RGU or Robert Gordon University, we have strong work on electrolysis, which is hydrogen production, supported by EPSRC. The project is called Metasys. Also, we have a large fund called High One project that is looking at testing facilities for pipeline or a storage tank or even electrolyzer. So it's the very end before certification. If you want to test your product, you can also come to, as you said, high one through the testing facilities there. Okay. Uh, okay, move on to the next one, please.
I don't know why that's not going down. All right.
Okay.
Okay. That's so.
Okay.
I'm just going to thank you so much, Mamdud. I'm just going to give a brief overview of the Hydrogen Innovation Programme. This is funded by the Scottish Government, and it comprises of funding pot for collaborative research projects with academics and innovators, either startup companies or small companies looking to move into the hydrogen space. The Hydrogen Innovation Programme has been around since the January 2022, and it's just been extended to the end of June. We're looking after elections to confirm extension to the end of the financial year. In the meantime, we're now opening an expressions of interest for anyone who's looking for putting a proposal for industry engagement fund application, looking for innovation business development support or funding brokerage support, and also looking for partnerships and consortia building for larger projects. So you can find the form for the expression of interest on our ETP Hydrogen Innovation Programme webpage. We'll send all the links out after the event as well, so you'll have all of that to hand. So just as a quick synopsis, the role of the innovation programme is to support the hydrogen academic theme group, Mamdud, and the representatives from all universities, looking at cluster building, so developing the innovation community that we have here in the webinar and broader across Scotland, supporting the pathway to commercialisation and internationalisation, supporting incoming missions from other regions, funding brokerage and consortia building for projects, and the general hand-holding for research and innovation and research and development support. And we work with all of the other innovation support organisations across Scotland as part of Team Scotland, so the enterprise agencies and Scottish Government and any of the innovation facilities across, including the Scottish Hydrogen Innovation Network members, and also the Hydrogen Scotland trade association body as well. So we'll have a joined up approach to all of this. So the webinar series that we're just starting is looking to provide a springboard for forming new initiatives and collaborations and to showcase what we have ongoing at the moment with universities, specific collaborative projects, either between more than one university or with industry and any other non-academic partner. We want to promote knowledge exchange and awareness raising of what's going on, new areas that are just emerging, and also established initiatives. And we want to encourage new partnerships with and beyond the hydrogen and advanced fuels community, so across that whole all sectors that hydrogen might touch, but also all the engineering and energy sectors that might relate to hydrogen, which is quite expansive. So we want to bring together sort of innovative industry leaders and researchers, but we're looking to show early career research, research as well as established academic researchers and the companies that have been working together. So that's the map for the webinar series as a whole. Today, Mamdud and I work as a bit of a doubled act to support the presentation discussions. So we'll have Alex Leddy, who's the Managing Director of Sustainable Solutions, a spin out from Intervention Rentals. He's a director for that. Abdullah is a KTP associate working with Robert University and is working with Sustainable Solutions, Alex Leddy and his team. Then we have Christopher Dixon, who's a lecturer in science and engineering from the University of Dundee, who's worked on ETP projects before, and Dr. Zanshri Kai, the associate professor for energy and environmental engineering at Edinburgh Napier University. We'll then follow on with a panel discussion, Q&A. There'll be Q&A after each of the presentations on the actual presentations, and then we'll have a wider discussion about collaborations and potential partnerships. So we'll start off with Alex Leddy. Has Alex managed to get in? Are you there, Alex? If not, we'll start off with Abdullah. Mamdud, if you'd like to provide the intro to the project, and then we'll start off with Abdullah.
Yes, this is a KTP project or Knowledge Transfer Partnership project between Robert Gordon University and Sustainable Solution Intervention Rentals. Unfortunately, Alex Lady, who is the managing director of Sustainable Solution, he could not join us. Not because he's busy. He tried to log in, but somehow the system is not allowing him to get into this webinar series. Anyway, so I can talk some of the technical aspect or the business aspect of this project because I am the academic lead. Um, so it gives me immense pleasure to introduce Abdullah, who is a KTP associate working at the company with RGU, and he is trying to use waste heat and trying to use that waste heat to make it some valuable product. So his pathway is to take the waste heat, turning into electricity, and then use that electricity to produce hydrogen. If you look at the levelized cost of hydrogen, if you have done any of this, uh, the production of green hydrogen is quite expensive, and the main reason is the electricity price. We can directly couple electrolyzer with offshore wind, but we have to look at the utility factor because we cannot use 24 hours of offshore wind to generate hydrogen. On the other hand, waste heat is a waste heat which is available 24 hours, and we can turn that waste heat to intermediate electricity and then into green hydrogen. So Abdullah can give the technical details as much as he can under the protection of IP. I think this is because we are working with a company. So Abdullah is all yours.
Thank you, Professor. I'm Abdullah. As Professor mentioned, I'm working as a KTP associate, and here we are trying to build some technology to utilize waste heat and eventually make green hydrogen. Uh, I will need to share my screen to PPT.
No, just tell me when you want to go down.
I'll just go down.
Oh, for some reason it's not working. Is that better?
Yeah. So I will briefly try to tell about the company operation and the type of collaboration we are doing. So Sustainable Solution is a green tech group under intervention rentals and focus on energy sustainability and efficient resource use across different industries, working to innovate energy solutions that improve sustainability while reducing carbon footprint. So the collaboration is a strategic partnership to research, model, and deploy hydrogen production using industrial waste heat, which is focusing on combining academic research with industrial practicality. And briefly, like why it matters, so hydrogen is central to net zero strategies as clean energy vector where electrification alone is not sufficient. And the next aim is like bridging the research and industry, accelerate innovation, adoption, and ensure scalable solution. Next slide, please. The company itself, Sustainable Solution, is working across different industries. So, general industries, and they provide different type of services and solutions to distilleries, through aquaculture to agriculture, and the hydrogen, which I'm the part of this team, what we are doing right now. Next slide, please.
Sorry, sometimes when I press it doesn't go. There we go. It's better.
Okay, so why we need hydrogen? Why so hype about hydrogen? So the current uses of industries in it is used in oil refining, fertilizer like ammonia production, methanol production, food production. Emerging uses is the transportation, which we can in near future will do some breakthroughs. So we can do the power generation and storage, and the factory and building heating, and steel and cement production. So there are so many uses of hydrogen. So that's why we need to make green hydrogen rather than just make hydrogen from other ways. So essential for decarbonizing industrial where electrification is not enough. So it can be produced from water and can be generated from renewable energies, which is abundant in the nature. And this is can be used across different sectors, so it's versatile and scalable. So that's why like hydrogen is very promising, and it is the future economy, what researchers believe. Next slide, please. Okay, so I will briefly talk about the waste heat potential in whole UK. Specifically, the most high one is the from the electricity generation. So, like 82% waste heat in the UK um, is available from the different power plants and different setup which produce electricity generation. From metal processing is 2%. From vehicle manufacturing is 4%. There's a good potential of food and beverage production, which is 5% of the total waste heat generated in the UK, and the chemical processing is 6%, and 1% is mineral processing. So we look at the map. So this is the Aberdeenshire. Scotland itself has a lot of potential of waste heat in gigawatts. So there's a lot of waste heat available, and we need to utilize it for commercial application. So to ensure the sustainability, can we go to the next slide, please? So again, here, if we look at the Aberdeenshire itself, it has a lot of potential of available waste heat. And if we go to the food and beverages, again, Aberdeenshire has many different food and beverage industries, and it have a lot of potential. So we can utilize that waste heat, and can produce green hydrogen. Can go to next slide, please. Okay, so this is the whole idea of what we are working on actually. So like some thermal energy which will be given to this cycle, it's a power cycle which we call organic Rankine cycle, and then that electricity produced by this primary system will be given to the electrolysis, and which in turn will produce hydrogen, and then we can store or transport this hydrogen. So this is the basic whole idea of the theme of our work we are trying to develop in intervention rental. So next slide, please. So this is a little like I will briefly discuss what we are trying to achieve. So uh, what we are doing is some mathematical modeling that map available waste heat sources across sectors and forecast the required hydrogen system size. This help determining technically viable deployment strategies and key performance indicator. So the next thing is the use of artificial intelligence and optimization. So AI can be utilized from real data across sector to improve predictive accuracy of system sizing, and has system performance under different operating condition, because the intermittent nature of the renewable surface heat itself make it complicated to design an integrated system. So identify optimization opportunities from heat to hydrogen conversion process. And the next what we are aiming for the predictive maintenance of a real plant operation. So we can how can we utilize the artificial intelligence to efficiently operate the plant, and at the end increase efficiency and reduce the hydrogen produce cost of the hydrogen produced. Next slide, please. So what output we are believing to achieve is production of pure green hydrogen, leveraging waste heat as a major energy input, alignment the net zero target and industrial decarbonization strategies. Scalable deployment begin with pilot studies, which we are aiming to high waste heat industries, and use predictive modeling to pinpoint the best location in industries, and move to industry-wide rollouts supported by standardized modeling framework. And system efficiency, which can be achieved by continuous learning from AI tools, which refine operational efficiencies, and predictive maintenance, reduce risk, improve uptime, and ensure stable hydrogen output. Next slide, please. Okay, so why does this matter to me are the sustainable solution or RGU? So the company is aiming to entry into the hydrogen energy transition market and a differentiator in delivering practical, scalable green energy solution and spearheading industrial sustainability practices. For RGU, RGU is continuously involved in the different hydrogen aspect of hydrogen research and real-world condition, establishing industry partnership and improving impact pathways and training next generation engineers cutting edge technologies. Next slide, please.
Oh, that's the last one. The last one was a thank you.
Okay, thank you so much for giving me time. And if you have any questions, so we can follow up.
Thank you so much. Mamdud, Alex, I think, is still struggling to get in. If you wouldn't mind giving a little bit of perspective from the company side of things and where that came from, that would be great.
Yes, the original company is Environment Intervention Rentals. They are a rental company. They rent out equipments, big and large equipment to oil and gas industry, mainly valves and also flow measuring devices. So they have been very successful in their oil and gas business. It's a what you call it, a kind of a family-run business, or shall I say, two friend uh, working as director and managing director in this company. However, they employ quite a number of people. So as I said, it's a very successful company, but they are looking into the future and energy transition. So they want to move into the energy transition and to future-proof their business. And waste heat recovery is one of the area they are working on. They have a partnership with an American company, those who are producing ORC, organic ranking cycle. So our idea came, discussion with them is that instead of producing electricity from ORC, why don't you add further value into the system? And that's why we are thinking of integrating system integration of ORC with a PEM electrolyzer to produce hydrogen and then sell the hydrogen. So there are two aspects of this business. One is to uh, 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 sell the whole system, ORC plus electrolyzer, because these are bought off the shelf, and then you sell it to companies, those who have waste heat. So that's the whole idea, creating hydrogen business for others. But this intervention rental will bring ORC and bring electrolysis, system integration expertise, and sell that into those companies who have waste heat. And they can then take the hydrogen and then sell it into market. That's the idea of the project. They are still developing their business plan and how much cost they can reduce in hydrogen production, but that's the separate issue. We are the current project looking at technical aspect of integrating system integration basically. We are developing some system integration code using Python first principle to look at if you have a waste heat over 24 hours over the whole year, how much hydrogen you can produce basically during seasonal variation and things like that. Those are the forecasts we are doing, and we'll use that data to train our AI model. So ultimately, we'll move on to AI model. Okay, so that's the whole conceptual idea. Thank you.
Thanks so much, Mamdud. Just go into a brief Q&A. Did you want to start off, Mamdud, or one of the panel members?
Yeah, panel member, can you start? Or I can. Yeah, any questions? Please go ahead. So is the
Just checking the chat.
Okay, so while we
Yes,
are waiting, yeah,
introductions.
Christopher, please.
I haven't got any questions in the chat. Are there any questions from the panel?
Christopher has got a question.
Thanks, you. Yeah, just a fairly basic question. Thanks for the presentation. I'm just wondering about the projected cost of the process, because one of the really important things is how cheap can we get the production of hydrogen. So perhaps you could just talk about some of the sort of expectations of cost, the challenges with that, and how it may compare to direct wind powered electrolysis.
Abdullah, are you still there?
Yeah.
Okay. Do you want to repeat the question, Chris?
Okay.
sorry.
So,
Okay.
regarding the cost of green hydrogen itself, a little expensive than the other form because the other technologies are more developed, um, like the other ways, the gray hydrogen or blue hydrogen. And this technology needs some infrastructure and investment at the moment. So, yeah, it's competitive, but we believe like there's a lot of potential, not just in UK, in the whole globe of waste heat, and which is like never utilized. So if we can utilize that waste heat in a long run, the hydrogen produced from the green hydrogen produced will be have a competitive price. So yeah, like it's a trade-off at the moment. It's not clear like the green hydrogen how much expensive or how much cheaper than the other technologies which we are using to make hydrogen. So, but like for a net zero, this is sustainable. The option of green hydrogen is sustainable. So at the moment, it might be not very competitive compared to the other, but in near future, it's the sustainable way of making hydrogen. I hope it helps.
Yeah, if I can answer that, is that if you look at electrolyzer, because this proposed system using electrolyzer, so there is no cost benefit in there. So only benefit will come because we are having waste heat, which is wasted, so we can recover that, and the capex of ORC system. Because if you produce electricity with a waste heat, and if you think about capex, so electricity price is very low compared to what we are buying off the grid. So that where the benefit of green hydrogen production coming, because the actually green hydrogen production main cost of is actually electricity, not electrolyzer, not water. It's actually the electricity, and unless we can reduce electricity cost on the grid, it will be very expensive. We talked about using curtailed wind for electrolyzer production. That's fine, but in that case, utility factor comes down to 10 or 20% because you have an expensive electrolyzer which is sitting most of the time. You are using maybe 3 hours, 4 hours in a 24 hours time. So that doesn't give you the levelized cost reduction. So it's whether you have to use 24 hours and then get a cheap electricity. That's where the benefit will come from the cost reduction. Thank you.
So just
Okay.
checking, is there any more questions from the chat?
No, we don't have. Okay.
So I
yeah,
have
go
a
ahead.
question.
Yeah.
So do you use the waste heat to generate electricity or the waste heat to provide the heating for the PEM to generate the hydrogen?
No, it's wasted to electricity through a organic Rankine cycle. So it's like a standard Rankine cycle, but the fluid can be vaporized at 70 or 80 degrees Celsius temperature. So it's a organic refrigerant fluid, right,
So
Abdullah?
what is the efficiency you expect based on the
Efficiency
model?
of the system is 30% in the electricity production.
30%.
Yeah, electricity production, and electrolyzer has got 60% efficiency. 59, 60, yeah.
Thank you.
Thank you.
So just an update, Alex Legge's not able to get to
Yeah.
join us. He's been trying an IT on this on the case to try and sort it out. So I have no
Yeah.
idea why you guys can get in and he can't.
Yeah.
Especially had a meeting with him this morning. So I'm
Yeah.
afraid we're going to have to give up on trying to get Alex to join us. And shall we move on to Chris, unless there are any other questions before we move on?
No, we don't have. Yeah, move on to Chris, please.
Okay.
Okay, everyone. Yeah, so I'm Chris Dixon, and I'll talk about a project that I was involved in over the last few years, and it was based on green hydrogen hubs and the sort of target. It was really a generation-based project, and we obviously looked at the where the hydrogen could go as well. So the sort of key theme was into heavy-duty transport and other routes such as synthetic fuels. So it was part of it was 4 of us involved in the project, but I'm here today, so I'll just talk about myself really, I guess. So I'm University of Dundee. I'm a lecturer. I'm not really doing a great deal of research at the moment, unfortunately, due to the demands of teaching. But my sort of long-standing interest has been renewables, and I teach most of the renewable energy technology at that university, the power engineering, and I've got some other little bits and pieces I do as well. So my recent research is, or really all my research, really been about green hydrogen and renewable energy. With a bit of sort of power engineering thrown in, and I've done 3 projects with ETP, which is now SPEERI essentially, and one with Transport Scotland in recent years. Next slide, please. So we'll talk about this project I did. It was what we call the ARM Hub in Brecon and in Angus. So it's a small town, and it's got one very large estate essentially around the town, and the estate contacted us in the past and asked us if we would help with their venture. So around about 2022, we were brought into this on the first ETP funded project, and there was a fusion between the estate and Angus Council. They had this drive to produce a green energy park with quite a diverse strategy. So we came in just to provide some bits of academic backup, some numbers, some theory, etc. And on this map, you can see this is the sort of overlay of the site. So that's one part of the estate land, just to the south of Brecon. It covers I think that's the South Esk is the river, and there's a bit of, sort of uplands. And there's a few areas which we've highlighted on this. This is just taken out of our report work. So the little grey patches towards the sort of bottom left are potential wind turbine sites. And there's a kind of light-coloured highlighted block area just to the left of the word Brecon, and that's the actual sites of interest. So that's where the sort of the main site was going to be. And there was also right in the middle a place called Stanicky, which is it's got a quarry there, and that was an interesting sort of brownfield site which we could have used. Next slide, please. So we started off with really quite a diverse plan. This was handled by the sort of master planner consultants. They had a broad range of ideas, just trying to stretch this out and see what they could actually do on the site. So this image is essentially overlaid on top of what was that little patch, that little ARM Hub site. So the main theme was going to be about HGV refueling. We're just off the A90, trying to pick up fleets of HGV vehicles. The council was interested in buying hydrogen-powered refuse collection. So there was a kind of a bit of a broad range of ideas as to where this hydrogen could go if we can generate it on the site. Next slide, please. The first ETP project was under the KEN 3, so Knowledge Exchange Network. We did that with a local energy consultant, and the main idea was just to see what they could actually do on the site. What are the sort of constraints? What are the scales of generation that we can have for renewables to create green hydrogen? And one of the key themes was to build this toolkit, because the estate had quite a large a vast estate of land there and elsewhere, and they wanted to see how this could maybe be rolled out to further projects, either their own land or other land, via the consultant, who was very interested to get our help to project this forward. So the key thing here is that it was like a transferable skill. So the toolkit was useful for the consultant to take on and maximize this sort of the transferability of the work, this funded work that we're doing. Unfortunately, the first thing we discovered was obviously the grid was constrained. As the local distribution grid was constrained, so that really put a big damper on the whole project. Unfortunately, probably the biggest challenge we had, and it's quite common now, unfortunately, in a lot of these rural sites. But we developed the toolkits and handed this over to the estate, and that led into the second project. Next slide, please. So this was under the HIP, the Hydrogen Innovation program, I guess. Sorry, I forgot that wrong. Hydrogen Innovation
Yeah.
Program.
That's right. That's right.
Yeah, thank you. So this was one of the more recent funding round, and we extended the project with the master planner, the consultant, a new consultant, to look at really crunching numbers. So we wanted to build a model that they could use, a theoretical model, to simulate different ranges of generation, demand profiles, different storage. So they could just look at a layout of how they're going to get enough hydrogen to serve the demands, and how it's going to be spaced out over the seasons as to what they expect to generate. So we had to really access quite a lot of data to generate a sort of monthly, weekly plan of expected hydrogen production throughout the seasons. And yeah, we brought in the sort of scalable factors for storage, different types of turbines and PV, etc. Alongside that, there was obviously work done on the commercial aspects of it. Next slide, please. Well, this is just some sample data. So what we did, we used an online database for solar and wind generation, and we had to calibrate that to our own measurements. So this is actually measurements from a nearby, it's not actually on the site, but it's a nearby weather station that we have at the university. And we checked the data from our data source with our own measurements just to see how it fares. So the orange line is the online data source, and the blue line is our own measured values. So with this, we were able to sort of validate the data source as being reasonably accurate for solar, and we did something very similar for wind. Solar is obviously a lot easier. So we had some confidence in the data going back, I believe it was 20 years of data. We were able to access half-hourly values of solar irradiation and something similar for wind. So we could see how the sort of daily, hourly, monthly, weekly sort of changes in the generation are going to likely to affect the site in terms of having a constant output of hydrogen. Can they actually achieve that, and what would be required to do that, and what are going to be the challenges in these different trends? Next slide, please. And on this next slide, this is some of the outputs from the model. So we just built a series of graphs and a relatively user-friendly model for the team to use, and they could just stick in numbers. They could just select a turbine, and they could select a size of storage, PV array. They had a room for about roughly 4 megawatts of wind and about 2 megawatts of PV, so they had plenty of space. Unfortunately, the grid obviously wasn't on their side. So we looked at different scales and crunched some numbers for them and gave them a whole printout of different scenarios, and they could see how it was going to fare across past years. Now, what we can't do is we can't say what it's going to do this year or next year, but what we can certainly say is what would it have done had it been on the site in these previous years, and they could see how the sort of monthly trends and the sort of typical outputs they're going to get, and where the sort of pinch points are and the stresses in the system. Next slide, please. And this actually led on to some other work. This is actually just a slight extension from the original ETP work. This is something that myself and Steve Reynolds, one of my colleagues, worked on alongside this project and until actually quite recently. And we looked at the idea of filling HGV vehicles. Now, the biggest problem is if the fleet of vehicles turns up and asks for hydrogen and you haven't got it. That was one of the biggest problems for this site. And we modelled different demand scenarios, and we also modelled when is it likely that there's going to be a fill failure, as in the vehicle turns up, an HGV turns up, and there's not enough hydrogen to refuel it. And that was one of the biggest challenges. So we took a great big array of data and looked at how we can balance the actual design of the system to minimize that, and what are the likeliness, how do we get rid of that likeliness of fill fail. So this was a slightly different bit of work. Next slide, please. One of the simple things we got from this was just how do we scale the wind and the solar. So the ideal factor was around about 1 unit of wind, about 1.45 solar on that particular site. Now, of course, there's a lot of practical factors. It may not be possible to actually achieve that, but that would be the sort of target, sort of unit sizes to get this to operate with a roughly balanced monthly generation of hydrogen, and that allows us to then commit to a sort of relatively stable output to the demand. Next slide, please. So really, just to sort of summarize some of the work we did and what came out of this, it was a lot of it was just desk-based computational. So we were crunching numbers alongside a consultant who was doing the business and the planning aspects. We obviously spent quite a lot of time up at the estate doing some land surveys. We did set an anemometer up on the site to sort of verify our data. So the key work was the sort of trying to build a data set and forecast the hourly or half-hourly energy on the site, and process that data and talk about some of the power systems engineering. So how are we physically going to build this microgrid? What are the components? What are the restrictions, to connect cables from one site to the actual demand? And just to kind of explain how this all is going to come together, what are the sort of subsystem dynamics in terms of the storage, if there is any, pumping gas into a tank, and the dynamics of the electrolyzer, the wind, the solar, etc. Tie it all together, and obviously discuss some of the control system requirements, which is quite bespoke in these cases. So yeah, we used historical data, and the idea was really just to refine their plans, to refine their projects, so that they could pick a reasonably reasonable scaling factor for all the parts, and how much hydrogen they're going to get. And our calculations, based on a range of different scenarios, was around about 50 to 90 tons per year, which was kind of entry level for them. And I guess some of the key things was keeping a very diversified plan, so having lots of avenues they can go down, and looking where the leaders are, where can they make money from this project. And obviously the key problem was the grid that was constrained, and that really put a massive hold up on the project. Next slide, please. Yeah, so actually, having looked at various other rural ventures and have had some involvement in them, the grid is the number one problem. So if you have a grid, if you have a 2-3 megawatt grid connection, you can generate relatively cheap electricity relatively easily, get your wind turbine and PV up and running, build a business out of that, get them churning out cash, and then you can tap into that relatively a very low cost energy source with an electrolyzer, and you just have to scale it correctly, and you can make that work. But without the grid, it's very, very difficult to balance energy. And we looked at how that might be possible. That was one aspect of the work, in scaling the system and building strategies to balance the shortfalls within a reasonable plan. So that particular project, sorry, if you go back one slide, please, Tedra. So that particular project carried on. We're sitting on the back of it now. We're not working with them directly, and they've sort of changed their course slightly. Unfortunately, the original funding was just under £6 million they had for this project, timed out because they couldn't spend it fast enough, mainly because of the grid. The grid connection wasn't there, and that made a lot of challenges with making this work. And the local council, Angus Council, took the money back and have now projected this forward into a new project. So the Arm Hub 2 is now up and running, or I should say it's in planning stages, and they're working with a new consultant planner for that, and we've been in touch with them as well. Next slide, please. Yeah, so this is a little snapshot of this new project. This is just off the A90 near the is it Orchid Bank industrial site, just off the road. They've got plans for HGV refueling. It may be electrified or hydrogen based. We're not sure at the moment. We're waiting for contractors to come in, decide what they want from it. But that's the current status of the project. It's moved to a new site, a new team, and the old one is looking at ways forward, obviously with private investment. Yes, that's everything from me. Thanks very much.
Yeah, that's a great presentation. So while our audience come up with a question, I have a question myself. You looked at solar and also wind, combination of solar and wind. So does the solar and wind complement each other? What I mean to say that you get solar energy during daytime and wind energy at night. So do they balance out, or you also need to have some storage?
Well, they do, yes. They definitely balance out quite well, actually. It's a very good asset if you can have. And obviously, we did look at the hydro generation. There is, I believe, there's a 100 kilowatt hydrogen generator just off the site. But unfortunately, the flow of river wasn't really practical for us to develop on the estate land. But yes, having all three is great. But clearly, wind and solar together work very well. So you do get, with the right balance of ratings, you do get, on average, you get about the same amount of energy per month. And as you say, in the summer, you're always going to get daytime generation. The slight problem with wind is that, and the winter months, is it's very volatile. The volatility goes up in the winter because wind can do a great deal or nothing, but you're going to get almost no solar, so you don't have that steady input. Yeah, so it's
a seasonal variation rather than day and night variation, right?
Say that again, sorry.
So it's a seasonal variation, big seasonal variation between summer and winter.
It certainly is for the two technologies, yes. So wind in Scotland, generally you get about half in the summer versus the winter. But with solar,
Right.
it's about 10 or 15. So you have to have both technologies really to build more stability into your daily, weekly generation. But I say the problem is in the winter, but when you can get days where there's no sun and there's no wind, and it can go on for a few days, whereas in the summer you don't tend to get that problem. But you do get the night times that are, you could have nothing at night quite commonly in the
Right.
summer. Yeah.
Okay. That's quite
The question from
interesting.
Mark.
Mark,
Mark Sari, any thought
Yeah.
given to an off-grid solution, also battery storage in the event of electricity overproduction? Just a quick answer here before we need to move on to Sanshri.
There was quite a lot of thought put into that. Yeah. So basically, with a 50 kilowatt constrained grid, we were pretty much a microgrid off-grid system, and that was really the problem. So how do we make that work? Well, it comes down to very careful balancing of the system. So that was really what a lot of the work was about. Yes, some batterification would be required inevitably, really just for stability of the system, because it's not great to have, if you have a fault, if you're running off a wind turbine and there's a fault, it's going to go down and it can cause problems with certain types of electrolysis and the general system. So yeah, you need a small amount of batterification, but as minimal as possible. And that was one of the things we did. We minimized the battery to what was the working capacity of it at the absolute minimum. And it actually turned out to be quite a small energy storage capacity, but quite a high peak power amount. And the rest of it was based on how much hydrogen, how big can you make your tank? How do you scale the electrolyzer to the wind and solar? Unfortunately, you have to overscale it slightly in these situations. That's the problem when you haven't got the grid. Your electrolyzer's got to be able to take a bit more power than it really needs to.
Great work.
We'll move on to Zansi just now, and if there are any further questions, we can bring back bring them back into the final session.
Sure.
Go ahead.
Good afternoon. My name is Chansi Kai, and I'm associate professor in energy and environmental engineering. My research is mainly working on modeling underground hydrogen storage and intelligent renewable energy system. And today I'm going to talk about three projects. One is funded by Royal Academy of Engineering and Net Zero Technology Center and Central Storage. So when you look at the UK, we have a leading in the wind energy installation overall onshore and offshore. So far as 16 gigawatts now in the left-hand side onshore, in the right-hand side offshore. Next slide, please. So when you look at that, we have a plenty of the installation of the wind, but if you look at our study in 2001 is quota of energy just 4 terawatts. In 2025, it's 10 terawatts now. It costs about 400 millions, and 98% of wind energy is quoted from Scotland. So because we quotate the energy generation from the north and as the south generates in the electricity, and the total cost is over £1 billion per year. So our studies say, okay, if we have a huge quoted energy, can we convert this energy into the hydrogen and storage? And next slide. In the subsurface, because here is a technology proposed to use wind energy converts to the green hydrogen generation. Once you have a vast hydrogen generation, is possibly do some seasonal storage and store the energy, the surface energy from summer to the winter. So that is a come up. We can leverage the depleted oil field in the North Sea and all etc. to as a storage facility. And next slide. So when you look about the underground hydrogen storage, there's a three typical case. One is in a cavern. It's a quite mature technology, but it's mainly for the compressed air storage in the left-hand side. The second one is never used for the hydrogen storage. That is a depleted oil and gas fuel. And today my work is mainly focused on the defeat gas fuel and the source carbon. Next slide, please. So when you look at the underground hydrogen storage potential, if you look at offshore, we in the middle, in the left-hand side, we have a lot of the depleted gas and oil fuel, and in the same time, there's a lot of installation or planning gas wind energy installation. So existing, they also have a existing, the middle charge is about existing gas pipeline. Maybe can you use or repurpose to use for transport hydrogen. When you look at in the right-hand side, one is the carbon, raw carbon offshore. The dashed point is what in just east of the hole. There's a huge carbon geology. You know, soil geology can develop carbon on source carbon on offshore, but also there's some dots on the onshore as well. There's a two potential. One is deplete gas and oil fuel, and one is a carbon, source carbon. Next, please. So be able to do this simulation, we got the funding from Royal Academy of Engineering. We developed a field scale, reservoir scale model. This model they call GPS flow. They can do a parallel computing, pressure up to 1,000 bar, temperature in 25 to 200 Celsius. You can do pure gas and gas mixed based on the real gas law. We have published that. If you're interested, the reference there. Next slide. We do a bit, especially for the gas mix, we do a bit of validations, look at the thermal property of the different gas in the subsurface. We quite confident with the model validation. Here, this is again some of the laboratory. Next slide. Once we have this model and we want to deploy this model in a real world application, that is a collaboration centrical storage limited, because they have three questions because we probably know centrical ROP is the largest underground gas storage for intersystem. And they were thinking about in the future repurpose ROP as a hydrogen storage facility. But they have three questions. We need to answer that first. First question is, what is the potential storage capacity for hydrogen? Second, because it's depleted gas fuel, what is quality of the gas in the production of the storage? The third one is, can you use the CO2 as a cushion gas for the storage? So next slide. So here in the left-hand side, the figure is a ROP reservoir, about 10 by 3 meters, but the reservoir is about 30 meters, about 30 meters thick. It's it's not very thick reservoir. On the top, they have about 800 soil carbon overlay, so it's quite a tight reservoir. Next slide. Okay, and we got an animation as well. Can you click at next slide again? Yes, okay. So this is the simulation. We've used the ROP 12-well simulation, use the injection extraction. And we do simulation for that. We look at the quality of the hydrogen generation. So overall, we have a volume percent is about 98% of purity of the hydrogen. Of course, we got methane in the natural gas in the mix. A different well have a different quality because of the heterogeneity. But the overall, we simulation based on the pressure provided by centrifugal, we can store 42 terawatt hour of the hydrogen. The working gas, because the ROP is intersystem storage, we just injection and extraction once per year. So the working gas capacity is 18 terawatt hour. But you see 42 kilowatts hour, the 58% is hydrogen and the kerosene gas. Next slide. Next slide, please. Okay, so because, and check it again, please, Natasha. Okay, because, no, and move back, please, that's okay. Because we the simulation say, okay, we'll have about 60% of the hydrogen as a kerosene gas won't produce any revenue. So Centrico said, can we replace of these 60% of the gas, use CO2 as a kerosene gas? But also, if you inject the CO2 as a kerosene gas, you're interested in what is extraction gas quality. If you look at the left-hand side, of course, when you use the CO2 as a kerosene gas, it will compromise some of the gas quality. But at the initial few cycle, the gas quality is about 80%, but it gradually increases about 90%. That is what we have in here. So that's that simulation CO2 can use as a kerosene gas, but will compromise the gas quality in the production. Next, please. Next slide, please. And we also use this model to do a carbon and hydrogen storage in the carbon, not only hydrogen, also other gas mixed, and 80% of the hydrogen and 20% of methane, or look at the pure methane. And look at the pressure evolution and the energy storage capacity of different type of gas. Next slide, please. So here the simulation, we look at the gas pressure and temperature fluctuation in different gas. The reason we look at the pressure and temperature fluctuation because they have implication to the integrities of the carbon. Because if you overpressure that temperature too high, can melt the carbon and cause leaking. We look at and the results show the hydrogen have a greatest range in terms of the pressure and temperature fluctuation for each cycle. The storage also tell that if you have the same carbon, if you want to use to store hydrogen, to just storage about 1/3 of the energy compared to natural gas. That is a key takeaway from our simulation. The next slide, please. Just going to wrap up today's presentation. We say in here we test the new simulator can be successful model hydrogen underground storage in the depleted gas fuel and carbon. And for the ROB, the total storage capacity of if we use hydrogen as 42 terawatt hour, and each year you can cycle the working gas at 18 terawatt hour. Yes, CO2 can use for the kerosene gas for the ROB and save a lot of money, but eventually will compromise the hydrogen quality in the gas production. So if we have a carbon and original to storage natural gas, if you want to switch to store pure hydrogen, you probably expect your storage capacity is just 1/3 of the same for the carbon. This means perhaps the potential will reduce the revenue. Okay, that is what I have for today. I just don't know if there any question from the audience.
Yes, thank you very much for your presentation. Quite a number of questions we have from the audience. So if I can ask you the first one, offshore storage, is it vulnerable to hostile action from other countries?
It's vulnerable. Okay, perhaps you because we have, if you look at the offshore North Sea, the oil and gas, this have been there many years, but perhaps there's a vulnerable, but compared to other type of the about surface storage maybe is more safe compared to that. But of course, we cannot say is no risk.
Mhm.
Yeah.
Very good. Another question is there is that what are the mitigations to minimize hydrogen leakage from storage solution and hydrogen
That
distribution?
that is a very hot question, honestly. But given the centrical, if it is a centrical storage, have been storage method for 30 years, of course, hydrogen is a small molecule, that's true. But yes, there's a potential leakage, but one of the leakage is because you need to select a site, a suitable site. You probably have to have a proper test before to conduct this hydrogen storage. It is one of the tasks. Centrical storage is also want to look at that as well. That's true. It's a legitimate. You have to before some of that before you do use any site for hydrogen storage. You have to do a bit further test. That's what my answer. Yeah.
And final question, Abdullah, you can ask directly if you are interested.
Okay, so my first of all, thank you for such a fantastic presentation. It was very knowledgeable. My question is like a very generic and general question, like what is the expected storage efficiency of the underground storage of hydrogen?
If you look at the storage efficiency, it depends. If you look at the ROP case, if we don't use CO2 as a current gas, you probably got efficiency is about you got a 40% of storage of the gas can be used as working gas, but the other 60% of hydrogen have to stay in the reservoir to maintain the pressure. But if you use CO2, you probably compromise the CO2, you compromise the gas production a bit, but storage efficiency, it depends on side to side. Based on our study for the centrical, maybe you probably can use about 80% of the storage into the reservoir used as a working gas. I'm not
Okay,
sure
and
if I answer your question or not.
yeah, I got the answer. Thank you. And like the follow-up question, like for how long we can store this hydrogen in
This
the depleted oil
how
reserves?
long you can store hydrogen is a big question because the reason we use a ROP reservoir because the ROP reservoir have a very unique microbiology property because the reservoir is 92 degrees. So 92 degree, this one is the temperature, the environment is not, it's a bit hostile to microbiology stuff and to, because we all report microbial consume hydrogen and mitigation and converse in methane. But if you say how long, maybe it depends to side. You have to do a study based on the microbial activity and maybe have to use a long-term modeling and combine laboratory experiment and then can be explained, but cannot generalize in this case. Have to case by case, I guess.
Okay, okay. Thank you so much. Thank you for a
Thank you.
fantastic presentation.
Thank you all. Now we'll move on to the panel discussion. These are some of the bullet points that we like to discuss, but we have the three panel members that presented on this area. So, and also we have a number of industrial experts in our audience. So I will request anyone to ask question, and if the question is relevant to any of our panel member or the industrial audience that's sitting here or academic audience that's sitting there, if the question is relevant, please raise your hand and we'd like to hear from everyone, those who are present here. So first of all, let me start off myself. We're looking at industry and the policy needs. So those who are here, they are all interested about hydrogen, and we like to look at hydrogen used in industry. Basically, at the end of the day, we want to move on to hydrogen economy, and for the good of the nature, and we want to achieve net zero. So in terms of to achieve that quickly or sustainably or whatever way, we need industry and policy needs. So if I keep this discussion open and ask anyone to look at what is the main policy hindrance for making hydrogen economy, establish the hydrogen economy. So what do you feel, because those who are working in this field with your own expertise, look at what are the hindrance there in terms of making hydrogen deployment a lot quicker. So anyone can answer that. Floor is open. So I will ask any contribution from any of our panel member or any of the audience. Thank you. Let me see.
In my opinion, the first thing is the public awareness about hydrogen to get the hydrogen economy, and the policymakers, we need to make them aware, like there's a very big potential in hydrogen, so they can invest, and public can also in one way directly or indirectly start investing in hydrogen technology. So in my opinion, beside the technical aspect, public awareness is the most important thing to get the net zero economy and hydrogen economy.
Okay, so you are talking about public awareness. Okay, that's one critical point. We worked on public awareness, and there is a big project going on called 500, and that looking at putting hydrogen at home, okay, for heating and for cooking. And when you bring hydrogen gas at your home, you can understand what type of safety and reassessment has gone through, and people are start to accept once this project is implemented, to even happy to bring hydrogen gas in their home. Now there is a there is a negative feeling, maybe hydrogen combustible, it might explode and things like that, but that type of fear will go away when you have more demonstration project. Anyone want to contribute on this point?
I just want to take the point. We have been talking about hydrogen economy last 5 years, but it seems for me we haven't nurtured a market, demanding market. So at the initially, because we talk, obviously this is no demand at the moment. We not obviously demand at the moment. When there is a hydrogen things take off, the people say perhaps we'll blend the hydrogen a bit in the natural gas, and from the carbon footprint point, maybe not reduce a lot, but not wonder maybe if we can start this one, can and start the market. And obviously in here we have been talking about several years, but it seems it's no demand, no market. Just don't know what you can comment on that. But by the way, the China in the next 5 years are going to focus on hydrogen now.
Yes, I mean the cheapest electrolyzer is now in China, which is and the biggest one, which is based on alkaline electrolyzer, I think, the AEM electrolyzer. So in terms of market, I mean there is an existing market which is maybe small, but which is filled by the gray hydrogen. So if you produce gray hydrogen, the price is $1 per kg, and if you produce green hydrogen, price is $10 per kg or maybe $7 per kg. A lot of technology developer claiming it can be reduced to $2 per kg. I did some calculation for Bolivian government or policymaker, one of the senators actually from Bolivia. And after doing the calculation, I found there is no way electrolyzer itself can reduce the price of hydrogen. by improving its efficiency or increasing its duration. Only way you can reduce the price of green hydrogen is actually electricity price. So if our electricity price is coupled with gas price, we'll never be able to produce hydrogen at competitive price. It has to be decoupled. The electricity price has to be decoupled. So we talked about producing hydrogen using excess solar energy or excess wind energy. I did a calculation also, and based on that, we have found that if you want excess wind energy, offshore wind energy, excess offshore wind energy, even the price doesn't come down. It's about $5 per kg or $4 per kg, because your utilization factor goes down. If you have an expensive electrolyzer, which is only using 30% of the time, so again, you are losing a lot of valuable capex. So whatever you do, actually, it turned out electricity price is the main thing. So where we need a policy, how you can decouple electricity price from gas price, because even the solar energy or wind energy electricity price is coupled with the gas price. So that decoupling is needed, basically.
I totally agree what you say, all the calculation.
Yes.
But for all these emerging technology, and the government doing very well for the solar and the wind, give a subsidies when let the technology start. When you look at the solar, you have a huge feed-in tariff and wind. Now all these new emerging energies can live independent without government subsidies now. I just don't know why there's no policy to. We have track record to support the development of solar and wind, but why not? If it is think about seriously in the hydrogen economy, why not? There's no such policy for hydrogen.
True. There's a policy needed. What about? Let's look at. I think one of the industry expert here is from aviation industry. Can I have some input from the aviation point of view using hydrogen or looking at any of these sustainable fuel or advanced fuel into aviation?
Mark Sowery.
Sorry to put you on the spot, Mark. You like to contribute anything? I think he's here or not.
Hi there, guys. Sorry,
Yeah.
Could you
Sorry.
repeat that? Sorry.
So I wanted to hear your view about using hydrogen or alternative fuel into aviation sector.
Yeah, I was actually just writing. Sorry, I was distracted. I was actually writing a long-winded question on that very issue. So my apologies. Yeah, what it is really is, I think, aside from the obvious issues of developing systems on board aircraft to handle hydrogen effectively, and the certifications being there from the regulatory authorities, which are significant barriers to be overcome. There's a whole ecosystem, not just in aviation, but any application you're going to use hydrogen in, because it's a different performing energy vector, hellishly combustible, and it releases an awful lot of energy when it does catch fire. Then, for example, with aviation, you're looking at new embarkment and disembarkment possibilities for passengers, should the aircraft even be parked near the passenger terminal because of the explosive risk of fire, for example. Should aircraft be defueled and refueled, again, remotely? And I'll just have a quick look at my question I was going to ask, actually. Then you've got the issues around the training of employees in fuel handling, fire handling protocols, and other things. So there's quite a large ecosystem around the use of hydrogen, rather than in addition to just the infrastructure itself.
That's a great point in terms of education. not only at the high level PhD type education, because when we talk about hydrogen education, it's actually now at a PhD or postdoc level training. But how you handle fuel, pumping, and things like that, those are the key critical issues. And we have to train whole lot of people in different area of hydrogen.
So
Mark
yeah,
Shiner's
sorry,
got a comment on the Mark Shiner's got a comment on the operation and training as well.
Yeah.
Yeah, sorry, I was
from
going to say, a final point there. I mean, I fully agree. I mean, and the budget just for training could be very significant, never mind all the other issues. And that, I'm not saying we're going to overlook it, but I think that's something that can get lost in the enthusiasm for the actual raw technology itself.
Mark, you were
Excellent
mentioning,
point.
yeah.
And then Mark Shiner has got
China, yes.
Yeah.
No, just very happy to briefly comment. Obviously, I can't discuss companies and commercial information, but we have a number of large vessels in the design stage and pre-construction stage, which are hoping to use liquid hydrogen as fuel. We've trained a number of vessel crews already. We have the only government-approved ships cruise training course in the world at the moment.
All right.
Is that UHI, yes?
It's UHI Orkney Maritime Studies, yes. And I think my point is to contribute to the market debate. If these vessels were to appear instantaneously right now, they obviously would not be able to obtain the green hydrogen that their operators would love to be able to use. And I think they would struggle to obtain any other colours of hydrogen to fuel them. But we're certainly working with 3 different companies. One of them is a design house that really want to go ahead. And they've very recently moved from looking at gaseous fuel solutions to liquid. I think liquid has recently become less scary for vessel designers. Anyway, I'll leave it there, but I think that's an interesting market area.
Great. Yeah, I mean, we have spoken another company. They haven't. They are putting on a big hydrogen production facilities. It's in an unknown place. They haven't disclosed the area. They are looking at 2 areas, but their whole concept is to export hydrogen to Germany, and they have already got agreement with Germany to supply hydrogen, and that will be in a liquid form, as you said, by boat, rather than waiting for pipeline installation and things like that. They will use boat and to liquid hydrogen to Germany. So that's liquid. Yeah, that's gaining a lot of attention now. Liquid hydrogen in terms of storage and transport. Okay.
Alf had a comment about policy and regulatory clarity. Alfonso, would you like to make a comment on that?
No, sorry. I think probably I'm stating the obvious here,
Yes.
but I think if we don't have the support from a clear guideline of where we're going, that's going to end up spooking, investors and even companies. Locally, we've seen this in Aberdeen recently, and this has massive effects locally. So yeah, absolutely. I think this is one of the things that we need to have clarity. I think we've been lucky enough in the UK for the last few years to have a clear mandate, and I think we should push that, because otherwise we're going to lose track with our European colleagues and friends. I think the EU is going to keep on investing millions and billions in hydrogen, and we're going to lose the opportunity locally and as a country.
Exactly. I mean, the recent bus Tuge from in Aberdeen, that is created a kind of a negative vibe around hydrogen, but we don't know the details of this project. But then hydrogen has a lot of uses in many different sectors. Probably city bus is not one of them, but long distance travel, ship and things like that, or a train.
I think the world wasn't ready for us. I think the world wasn't ready for us. I think we were very quick in that sense, and they didn't. But it's true that like the public, and that links to the first question or the first comment about engaging and public awareness is so important, because in the end of the day, public is going to vote for the leaders, and the leaders are going to have an important view on policy making. So if we don't make it happen at a low level, it's never going to, get up to Westminster and Holyrood, in the case of Scotland at least. So yeah, we have a lot of work to do to go out from our offices and labs and spread the word. So yeah, which I think we're doing anyway, but even more is necessary. So
yeah, that's great. Thank you. Okay, who else is there? Looking forward to afternoon.
We have some comments about collaboration opportunities. People are interested in certain types of collaboration, but it'd be good to get an idea from the panel what sort of collaboration opportunities they're looking for, and then anyone else to add to that.
Christopher.
Just, I can start off with just to say that I'm obviously university based, and I'm here if anyone from industry is interested in getting in touch about projects. I mean, there's a lot of barriers to some of these, and they may want just to talk it through with someone and get an understanding of what they might be able to do or not. I probably haven't got a great deal of time to engage in a very large long-term project, but I can certainly sit in the background and offer some help in any way I can. So feel free to get in touch. I've had a few people email me and message me in the last few minutes, and I'll get back to you as soon as I can.
Yeah, that's good. Thank you. And
it's great to hear there's already some engagement going on. So please do contact each other directly. You don't have to go through us, but again, we're here to support as well.
And that is a fantastic project, actually. We need this type of project, many of this type of project, actually, to do the feasibility study, to look at how much hydrogen we can produce, how much it will be cost, and things like that in different locations. Because the technology, to my mind, technology has reached a point now where it can be deployable. I mean, in terms of electrolyzer, even PEM electrolyzer is actually market ready. AEM has been in use for a long time. So these are the two technologies that are actually at a commercial stage. Solid oxide is still in the development phase, but the other two can be employed. So we need much more demonstration project, much more visibility, and some of the demonstration project we cannot do from the university. It needs collaboration with industry and local authority and all other stakeholders. And funding, of course, is a issue where this type of demonstration project, we need money from what do you call Innovate UK, or what's the funding body?
UKRI.
UK, not that. I think it's a Innovate UK.
Yeah.
Innovate UK. Yeah.
Yeah, it's the same thing these days. They've all come together. Zanzi's got his hand up.
Just want to have a quick note for industry. If you have a site or whatever, want to test for the storage, and we have this GPS phone, we have IP, so we can collaborate in terms of PhD or MSc student, whatever, to start it from small, and then if you want to go to Innovate UK, then we can move on. But it'd be interesting from small scale. We're also interested in collaborate with industry, like we collaborate with centrifugal storage limit. So just it. Yeah.
Great.
We've had a couple of people, Nathan Silken from the International Centre for Brewing Distilling at Heriot-Watt, looking for collaboration as well. And there's also, that was Mark as well, looking for green hydrogen solutions as an energy director for aviation and off-grid solutions as well. So there's a few comments there. We're going to have to wrap up just now. So if any other questions or collaborations, please note them down in the chat. I know people need to run off for other meetings, so if we just do a quick wrap up just now, and you can always get in touch with us again at any time. Just to say the upcoming events that we have 2 events at All Energy, well, 4, but 2 hydrogen focused. So one of them is the Hydrogen All Energy Masterclass. You'll see Mamdud again there. That's, I think it's on the show floor theatre. Is that right, Jenny?
Yeah.
That's from 16:30 to 17:15 on the first day. And then we have Cross-Tech workshop series. There are 3 workshops on that day at 11:10 till 13:10 at the Dohart room. The 3rd workshop will be the hydrogen-focused one on engineering, transport and storage solutions from 12:30 to 13:10. So you're welcome to join us there. And then we have the 2 next hydrogen and advanced fuel webinar series sessions. So the next one is an extended version, an EP, if you're back in the old type of extended records. Hydrogen fuel special, so that's at 12:30 to 14:30. We'll have Kim McCann from Protium and SLR Consulting doing a global overview of hydrogen strategy and policy and the role of hydrogen fuels across the globe, the opportunity, the UK's position within that, and the Scottish opportunity. The session will be led by the University of Glasgow, Prof. Manoj Paul and his colleagues. They will be presenting some of the research areas, and we'll also be joined by, I've forgotten. Mamdud, remind me. Sudaga from Heriot-Watt University. Yeah. And there's one other person to confirm as well for that one. And then hydrogen transport and storage the following month. We will have Flexigy and a company from Glasgow University as well. So all the details will be on the webpage as we get confirmations of the speakers, but it'll be a similar format to today with presentations and discussion as well. Mamdud, would you like to say anything in terms of wrap up for the session?
I would like to thank you all the speaker and also the attendee, those who came to listen to the presentation, and not only that, to contribute to the discussion. Okay, we'll keep on not only on the discussing around the area, but we're also interested to do work. So collaboration is the key, as I said, because some of the challenges are so big within instead of working in our own isolated way. If you do collaboration and look at the system approach, I think we can implement many of the project a lot faster. So having said that, we'll open, as I said, open to collaboration, and anything related to hydrogen, if you contact directly to us or to Natasha, then we can distribute to different universities. We have the expertise within the 14 universities on all aspects of hydrogen. So if I cannot do it, may be done by Christopher or someone else. So we can look at the whole value chain of hydrogen. We have the expertise in whole system approach. So thank you, and we'll be welcoming you in the next webinar series.
Thank you also to my team, to Katrina and Jenny and Jen, who's not on the call at the moment, and Alex for promotion. Please let us know if you're looking to get support from the Hydrogen Innovation Programme. Go to our webpage, the Hydrogen Innovation Programme page, and there's an expression of interest form there. You can also email us directly, either of us. Do let us know if you're looking specifically for the European funding calls, because we're going to try and develop a brokerage session for consortia building beginning of June as well with the European Green Energy Centre, Scottish Enterprise, and other colleagues as well. So just let us know what you're looking to do, and if you're looking to collaborate, just come to any of us and we will help that process. Thank you. I'll let you go, and we'll hopefully see you at the next one or at All Energy. We'll have a stand there as well, so come and chat to us.
Thank you.
Thank you.
Thank you so much.
Okay,
Have a
thank
good
you
day.
very much.
Bye-bye.
Bye, everybody.
Thank you very much. Bye.